Prime factorization is a special way to factor numbers, or a special way to write the number as a product of its prime factors. So first off, it helps if we know what all the primes are, and we've seen that before. The smallest prime number is 2. It's also the only even prime number. Then we have 3, 5, 7, 11, 13, 17, 19, and it goes on forever. So again, prime numbers are special numbers. They only have two factors, 1 and themselves. So to write a prime factorization, all you have to do is take a number, let's say 15, and think of the smallest prime factor that it has. Well, go down the list. 2 is not a factor of 15. 3 is a factor of 15. So write 15 as 3 times whatever the result is, 15 divided by 3, which is 5. And you stop when all of the end branches here are prime numbers, and 3 is a prime number, 5 is a prime number. So that means you can write 15 as simply the product of 3 and 5, and that would be the prime factorization of 15. So let's try that again with a number like 105. So we start with the smallest prime number, 2. That's not a factor. 3 is a factor of 105. 3 is 3 times 35. And then we work on 35. And we shouldn't see any primes that are smaller than what we've already got up to on the list, but we should try 3 again and see if we can pull out 3. 3 is not a factor of 35, but 5 is. So we can write 35 as 5 times 7. And we know to stop there because 3, 5, and 7 are all prime numbers. And so the prime factorization of 105 is 3 times 5 times 7. So what if we have repeated primes in our factor list? So let's take a look at a small number like 20. So we start again with the first prime on the list, 2. 20 is just 2 times 10. And we continue trying to pull out factors of 2 from 10, and sure enough 10 is just 2 times 5. So here we have repeated primes, and it's important to recognize that we have repeated primes. So we could write 20 as 2 times 2 times 5. Now, with prime factorization, this is normally written using exponentials, and we'll see exponents a little bit later on if you're not that comfortable with them. So 2 times 2 you can write as 2 to the power of 2 times 5. Try this one more time. Let's say we have 180. So we try to look for factors of 2. There is indeed a factor of 2. 180 is 2 times 90. We can keep on pulling out 2's. 90 is 2 times 45. No more 2's, so we start looking for 3's. 45 is 3 times 15. Keep on pulling out as many 3's as we can. 15 is 3 times 5. All of the end branches now are primes. So what do we have? We have 2 2's. Using exponential notation, we'd write that as 2 to the power of 2. We have 2 3's. Again, using exponential notation, write that as 3 to the power of 2, and we have 1 5. So 180 is 2 to the power of 2 times 3 to the power of 2 times 5.